Okay, I'm going to show you how to use SPSS to calculate the sample standard deviation. SPSS gives you the estimated population, standard deviation, and variance. And I've gone through in class how to do this, right? So up here, this is S sub X, SX. This is the sample standard deviation. If you look down here on the bottom right, that's what the estimated population standard deviation would be. So let's go over to SPSS. And again, I am using the app. Okay. So I have created X here. And if you remember, we want to calculate the deviation. And then we're going to want to sum that up. So let's go back up and look one more time. Okay. So we're going to replicate this on SPSS. So here we have the X column. We're going to calculate the deviation, which is X minus the mean of X. And then we're going to calculate the squared deviations. Okay. And this right here will be the sum of squares, the sum of the squared deviations, right? Okay. So to calculate the deviations, we need to get the mean of X. So the first step is to do analyze. We're going to use descriptives as the easiest, descriptives, and put our X variable over there. Press OK. In the output, we see N 10 cases or scores, minimum 1, maximum 11. The mean is 5.30. And the standard deviation is 3.592. So that's the estimated population standard deviation, which uses n minus 1 in the denominator beneath the radical. So let's, with a mean of 5.30, we can now compute the deviations. So we hit transform, compute variable. We're going to name the variable deviation. And the deviation is just X minus 5.30. Of course, we could also do different code to get it, but this is the easiest, okay? Okay. Okay, so now we see over here, we have the column, and actually we should change X to scale, okay? We have a column with the deviation, so we'll check it. The mean is 5.3. Well, 10 minus 5.3 is 4.0. So that looks good. This is the deviations, okay? X minus the mean of X. Next, we need to calculate the squared deviations. So that's really easy. Transform, compute variable. And we're going to just do SQ deviation. Okay. We're going to clear this off. We're going to go deviation times deviation, okay? And here we have squared deviations. We could click over here and give it a label, squared deviation, okay? Because we don't have that fully in. And we could also, oh, but we actually need the decimals here, don't we? Okay. Here we have pretty much everything we need. Okay, to check our work, we could simply run descriptive statistics, descriptives. I want to put them all in there. Remember, the deviation, the sum of the deviation should be 0. So if we want to test that, we come here and select sum. Let's get the variance too. Continue. Okay. IBM really wants my feedback. Okay, here we go. So we have for deviation, sum is 0. Good. We did our work. Square deviations. We have the sum, which we're going to need because, again, we're going to look at our formula. Okay. It's the square root of the sum of the deviations, right? This is the sum of the squares right here, divided by the sample size. Okay. So we're going to calculate, actually, we'll do the sample variance and the sample standard deviation. Sample variance is just without the radical. Okay, so let's go back to our SPSS. Share. Okay. So the sum of squares, the square deviation, is 116.10. So standard deviation and equals just sigma. This is actually, I'm just going to put sums of squares, or I'll write it down. Sums. Sorry about the mess here. X minus the mean of X squared over N. So sums of squares is right here. All right. So we go square root of 116.1 over N is 10. All right. And here is when we have to get out. Oops, that's supposed to be 10 at the bottom. Our calculators. Okay. So we have this part we can do in our heads. 161. So let's see. I have to get my fancy calculator. Square root is 3.4073. Okay. This is the sample standard deviation. Okay. If we look at, if we're treating this as if we want the estimated population standard deviation, it's going to be really different. It's going to be right here, right? Which is what we should get checking our work if we do n minus 1 in the denominator. So if we do, let's calculate the population standard deviation equals square root of 116.1 over n minus 1, which is 9. So I'm going to calculate that to make sure I didn't make a mistake somewhere. So this is equal to the square root of 12.9. Which is 3.592. 3.592, which we're correct because look, here's the standard deviation, the estimated population standard deviation of our sample of scores X. All right, that's how you calculate it. Of course, you could just take this, okay, and solve, right? You could just solve for the sample standard deviation as well, but I'll cover that, and that's simply algebra for solving for X actually. And you can do that without calculating this, but we're going to use SPSS to do Z-score, so it's good to use compute variable to do all these things.